All right, so rate of change shows the relationship between two changing quantities. Slope is the rate of change. It's another word for that. So you could just write rate of change, vertical change over horizontal change, or rise over run. Yeah, tons of applications of slope in real life. Miles per hour is like one of the best. If you're typing, do you guys do typing tests in your ICT class? Do you go through a program on there?
I hate ICT. Oh my god.
So you're going to do it. Okay, so anyways, in there you're going, so, okay, we can leave the comments. But anyways, you get a words per minute like you do sometimes. So you can, I don't know, sometimes you can get a certificate for words per minute, and that might help you get a job or whatever. If you're doing a lot of typing, it helps in college if you can type really quickly. The formula for finding slope, and we won't always use the formula. Sometimes you can just. Oh, you have a song for it. Look at that.
Why?
Well, because you have to memorize it. You have to know the slope formula. We'll also look at how to do this on a graph. Man, the biggest mistake students make is, well, this isn't about them, but the biggest mistake students make is switching up the y's and the x's. The y2 minus y1 over x2 minus x1, I'll show you when we get the examples what we mean by that. The subscripts mean two separate points. So given two separate points in the coordinate plane, you can find the slope using this formula. If you, this is a way hopefully to help you remember, undefined slope is if you have a number over 0. So remember, a number is n over 0, o. No is no, undefined. Whereas 0 over a number is ok. So 0 over a number, if the number is represented by k, is 0. So a slope of 0 would actually look like this, a horizontal line. And a slope of undefined would look like that. Yeah.
Why can't we just use y equals mx plus b?
Well, y equals mx plus b is the linear equation form. This is how you find the m part of it. So. Okay, we don't need to meet commentary there. Man, as if you're never wrong. All right. So next one here. Finding a rate of change using a table. We've done this before. I wanted to connect slope to what we've been doing. On the last test, when I had you guys look at the table, the y values of the table, right? And then if you notice that they were going up by the same amount, like here, they're, you guys, you can't, I know you can't. So go ahead and fill it in. It's 260, 520, it's pretty dark on your paper. 260, 520, 780, just write it to the side. 260, 520, let's do this, 780, 1040. But what you should notice is it's going up by 260 each time. So we know it's a linear equation. The slope, or average rate of change, is equal to 260 feet per 1 minute. And so we look at the data in the, or the stuff in the x part of the table. And if that's going up by 1, then this constant difference is our slope. And that rate of change represents feet per minute, 260 feet per minute. Now, even if you use non-consecutive rows, if I skip from 260 to 780, my difference there is 520, but what's my difference here from in the time units here? We go from 1 to 3, right? So if I take 520 and divide by 2 instead of 1, I'm still going to get the same slope of 260. That's actually how the formula works for slope. So sorry that didn't show up very well. Any of the things I copy over from the textbook. All right, I'd really like you to be able to look at these graphs and quickly tell me if they have positive slope, negative slope, zero slope, or undefined slope. Looking at this one, as we go up from left to right, if you're going up from left to right, it's like climbing a mountain. If you're ascending, it's positive slope. If you're descending, it's negative slope. We ought to be able to label the slope from the graph. This should be the easiest way to label slope. So we're going to use M for slope. And if this is a positive slope and I go up 2 units, it's going to be the vertical rise. So the vertical part will go on the top over the run, which is the horizontal part on the bottom. So it's always like that. In this case, M is equal to, we go up 2 and over 3. So that's my slope for the first one. And here the slope is down 1, 2, 3, 4. So we can put a negative 4 on there. You can actually, and then over 5. It doesn't matter where you place the negative. A lot of students like to think of when I go down, I'm going negative units. And then when I go right, I'm going positive. So it's a negative over a positive. But at the end, it's just a negative fraction. You can actually just get the slope, 4 over 5, and then apply the negative when you look at it kind of big picture. It's going down, so it's got to be negative. So however you want to think about that. Some students will say down is negative, left would be going negative. So you'd actually end up with here, if you went down and then left, a negative over a negative is a positive, which would be equivalent to what I get for the slope here. It's positive 2/3. So lots of different ways to think about that. Can you do the slope on these two? If you can see, you see on your graph these 2 points. If you can see these 2 points, how far up do we go? How far over do we go? Are you guys able to see this on your packet? Yeah. So count for me here. We're counting spaces. 1, 2, 3, 4, 5, and this is 1, 2. Looks like it's 2. 1, 2. So 5 over, and then it looks like it's 1, 2 up. So this would be a slope of 2/5. Is it positive or negative? Positive. It matches this guy going up from left to right. What about here? This is definitely negative. We're going down to 1, 2, 3, 4, 5, 6 over. So it's negative 2 over 6. Now they won't leave it like that. They will reduce it. It's equivalent to negative 1/3. So it's going to be in simplified fraction form. It says in part A of problem 2, pick 2 new points on the line to find the slope. Do you get the same slope? If I were to pick 2 new points, say I pick, let's see here if I can find 2 new points. The trick is finding 2 new points that are actually on the intersection of 2 grid lines here. It's a little tricky. Probably the best I can see here is to pick this point up here, which is 1, 2, 3, 4 down, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's going to be all the way over here. So this is not the best one to do this with. But 4 over 10 is exactly the same slope as 2 over 5 because 4 over 10 reduces to 2 over 5. So it doesn't matter which 2 points you pick. It's kind of helpful if on there I show you which 2 points I want you to use because sometimes it's hard to tell where those grid lines are crossing. So typically we'll have, when we want you to find the slope of the line between 2 points, I'll give you the 2 points. But if I don't, you pick 2 points and then go ahead and count how far up and over it is. Finding the slope using points. So this is using the actual formula that I gave you. So you should be able to find the slope just by looking at a graph and counting how far up and over or down and over. And also you should be able to do it with the formula. Now with the formula we label the first point x sub 1, y sub 1, and x sub 2, y sub 2 for the second point. It doesn't really matter which one you call the first point and the second point. It makes no difference. Until you go and plug it into the formula, we need to be consistent here. But you could switch these two. You just don't want to switch individual coordinates here. You wouldn't want to switch those up. So we have m equals, it's going to be y2, which is negative 2, minus y1, which is 0, over x2, which is 3, minus negative 1. And I'm just thinking in my head, I'm subtracting the y coordinates, so finding the difference between negative 2 and 0, and subtracting the x coordinates, negative 3 and negative 1. So I get negative 2 over 4, which simplifies to negative 1/2. So be really careful with those signs. See if you can find the slope between these next 2 points. Give you just about 30 seconds to try it. 30 seconds. Give you a few more seconds here, maybe 15 more seconds to get it. As you get more and more used to this, I mean, some of you could probably do this in your head. You've done it before, but it's negative 1 minus 3 gives me a... No, quite. We're going negative 1 and subtracting. Yeah, negative 4. 4 minus 1 is...
2.
Positive 3. It's good we're writing it down. That's right. So we got negative 4 over positive 3 is what you should have gotten. Hopefully you wrote it down and showed your work. What's that? What's that? This unit does get harder as we go along. Once we get to the point, kind of the big idea in this unit is I give you a couple points on the coordinate grid and you have to come up with the entire equation. So you're finding the slope of that triangle. And you should be able to write the equation in 3 different forms: standard, point slope, and slope intercept. So that's the goal. Okay. So it does get a little more difficult. This is not as difficult. Plot the points above and draw a line through them. Does the slope look positive or negative? So let's plot these points right up here. Just draw an XY grid. So there's the coordinate 1, 3. And then 1, 2, 3, 4, negative 1 would be over here. 4, negative 1. If I draw a line through those points, taking a step back and looking at it, does this look positive, negative? What does it look like? So we've got negative 4/3 of the slope. Does that look like a negative sloping line? You could then graphically count 1, 2, 3, 4 down and 3 over, and you see that you get the same slope. So graphically, algebraically, either way, you ought to be able to find the slope here. You have a negative sloping line from 1, 3 to 4, negative 1. Finding slopes of horizontal and vertical lines. So we've looked at positive and negative slope. When you see a horizontal line, you ought to be able to jump right to the slope. When it's horizontal, it's m equals 0. Here's why, and you don't need to show the algebra on this. If you see a horizontal line, you ought to be able to say that's 0. Here's why. 2 minus 2 over 2 minus negative 3 gives me 0 over the number 5, which reduces down to 0. And that will happen every time you have a horizontal line. The top will always be 0. This is the OK from our little check mark in the beginning. Okay, you have 0 over a number represented by k. I don't care what the number is, as long as it's not 0. That's an indeterminate form. But 0 over any number other than 0 is okay. Whereas here, this is a slope that is undefined. Here's why. Here's how we know. We can see it algebraically. When I calculate negative 2 minus 1 over negative 2 minus negative 2, I get a number, negative 3 over 0. And this is not okay. That's the no. That was the exclamation point. What's that? So undefined slope, I'd like you to be at a point where when you see a horizontal line, you just know the slope is 0. I mean, if you start thinking about how to, like, say you're looking at a ramp, you know, a wheelchair ramp or whatever, it's going to have a very small slope, maybe, I don't know, 4 or 6%. So that's measured up from 0%. 0 is level, like the ground here. Okay, it's very level. So what is the slope of the line through the given points? I think you could probably tell which graph this goes with. If I have 4, -3, and 4, 2, this goes back to my last chapter. This is one point on top of the other. What slope is that going to represent when I have one point stacked on top of another? Is it going to be the 0 slope or the undefined slope? Here's what the picture looks like. It's going to be undefined, yeah. Here I have 4, 2, and here I have 4, -3. That's definitely by picture undefined slope. What if you don't want to draw the picture? Okay, if you don't want to mess with the graph, you just do it. Yeah, just do the algebra. 2 minus -3 over 4 minus 4. You'll quickly see that I get a number 5 over 0. So this is undefined. Okay, hey guys, you just stop talking.
Yes.
And then this one, if I graph it over here, we can see a visual picture of it. 1, 2, 3, 4, 5. 1, 2, 3. 5, -3 is down here. -1, -3 is over here. Draw our horizontal line through there. You can see it algebraically. -3 minus -3 over 5 minus -1. -3 minus a -3 will give me 0. 5 minus a -1 is 6. So this is a slope m equal to 0. So you can see it either algebraically or by picture. But I'd like you to know that the slope of a horizontal line is 0 and of a vertical line is undefined. And then also be able to picture positive slope, negative slope. So those are the 4 cases all in one row there. A summary here. Maybe a summary would be the 4 types of slopes you could see. It's you know, I could calculate slopes of positive, negative, 0, and undefined lines. And hopefully you can. And you can do it either by a graph or by an equation. That's it. Starts off pretty easy. We're going to build from here. I have some practice for you to do. A lot of them are real quick. I have lots of variations: positives, negatives, some that are fractions, some that are whole numbers, undefined, 0. I want you to do 1 through 33. Odd in the classwork if you could right now.